with Sam, and we'll continue our talk today, our conference today with Sam and his talk on passwords. So before we get to the talk, I want to say big thanks again to our sponsors. Be sure to check them out. They're cool. They helped us a lot getting this conference up and running. And since, well, you're from Auth0, Sam, but in case you don't know, we're running also a challenge today with Auth0. It's throughout the whole conference, so the whole day, and you get a chance for a pair of headphones if you manage to get it up and running. It's a login challenge, let's say. And for all the front-end devs, the guys that like modern tech, GraphQL, or they're looking like a headless stack build-up for their modern app, or even better yet, e-commerce platform, e-commerce web app, then be sure to check out Crystallize. That's where I'm from, actually. And be sure to check it out, give it a look. It's a really cool combination of content and product information for your modern apps. So without further ado, I'm passing the torch to you, Sam. Thank you for taking the time to get this all together and doing the presentation for us. And yeah, that's pretty much it.
Thank you very much for that nice introduction, and thank you for having me. About the login challenge that we're running, if anybody runs into any problem, feel free to reach out to me on Twitter or in the chat here during my presentation, and I'll gladly help you after the talk. But that's about all I will say about Auth0, or almost everything during this talk, because I'd like to talk about passwords. And if you're very attached to passwords, if you love them, this might not be a talk for you, because I will basically just telling you that I don't really like them, and I think that they're horrible, horrible things. So the title of this talk, passwords are so 90-90. With that, I don't mean 90-90 like fashion that gets back into style or vintage music equipment that gets back into style. I mean 90-90 like it's old stuff and we should move away from it. But let me quickly introduce myself. My name is Sam Bellen. I'm a senior developer advocate engineer at Auth0. That's a mouthful, but it just means that I try to connect with developers worldwide, and in this case, here in React Norway. I'm also a Google developer expert, and you can find me all over the internet with the username SamBegel. I'm also a JavaScript developer, so it only makes sense to me that I'm npm installable. So if you run npx install npx @sambegel/about me, you can find all the links to my social media and to all my presentations right there in your terminal. So what I'm going to be talking about today, I already mentioned that I'm going to explain or try to explain why I don't like passwords. So we're going to start with a little bit of history on passwords. They go back way before 1990, actually. Then we're going to see a few different types of passwords. We're going to look into passwordless authentication. And lastly, we're going to the Web Authentication API, which is a newish API that might get us rid of passwords right now and in the future. So let's get started. A little bit of history on passwords. Somewhere a long time ago, before Christ, I don't have a number for you, I don't have a date, but a long time ago, there was the Roman Empire. They started, and passwords have been proven to date back at least to the Romans, but probably even before the Romans. And what this means is, back in the day of the Romans, when two legions of Roman soldiers would meet and they did not know each other, obviously because it was a big empire, it was a big group of people, they would often use a password to determine if they were friend or foe. And if they got the password right, they would go and drink a beer. And if they got it wrong, well, you can imagine what would happen with two legions of Roman soldiers. But if we skip forward a bit to the 10th century, this is after Christ, it's a little bit more recent. There's a story of 1001 Night in which you have Alibaba, which talks about a gang of thieves that steal treasures all over the country or all over the world, and they hide all of their gold and jewels inside a cave. And in order to open that cave, you had to say the magic phrase, "Open Sesame." And well, this "Open Sesame," even though this is fictional, of course, is a password to open that cave. But let's fast forward a bit to the computer age, to the modern age, and let's go to 1961. Fernando Corbato is often seen as the inventor or the person that came up with passwords first, because he worked at MIT labs and they had a time-sharing system. Now, back in 61, not everybody had a computer on their desk. They didn't have a cell phone in their pocket. MIT had one computer. But they liked as many people as possible to be able to use that computer. So everybody got an hour a day, let's say. And they all were able to do this with a system called time sharing system, where you would basically enter your password so that you would be able to see your files, and you got the computer for a short amount of time. And by entering that password, you would be sure that you were working on your files and not overriding somebody else's files, for example. Then let's skip forward a little bit more to the 70s, where Robert Morris Sr., which was an engineer at Bell Labs, invented hashing. And this is a crucial bit of information because it means that at least the first 10 years of passwords with computers were stored in plain text. As we now know, or should know, we don't store passwords in plain text in databases anymore, but we hash them, we salt them, we do different things with them so that they're not plain text in a database. And then from the 1990s, hacking became more of an issue just because we had the dot-com bubble, and we had a lot of companies that were moving online. And the more companies that appeared online, the more people got interested in hacking those companies. So back in the 90s, we weren't that, we didn't know that much about online security and how to store passwords and how to secure databases and stuff. So hacking became more of an issue, and it's still an issue today because when there's data to find, people are trying to get to that data no matter what. So there's a little bit of history of passwords. It started way before the Romans, but it moved on until the modern era, where we use passwords with our phones, with computers all the day, all the time, every day, day in, day out. So let's look at a few different types of passwords. The first one, before we can see these passwords, let's define what a password is. And to me, a password is anything that's a shared secret. So anything that's a shared secret, a secret between me and a third party, is a password for me in this presentation, at least. And the first is the most obvious, the most common example. It's a string. It's a word or a bunch of letters or a combination of letters, symbols, and numbers. Like, for example, password 1234. I hope nobody uses this as a real password, but a string is the first example of a password. My first password when I was very young and I set up my first Hotmail account was ColdDog. I don't know why it shows this. It's not a good password, but it shows this because I was young. I don't have that account anymore, and also it's not my password anymore, so don't even try. But usually a string these days, if it's a more secure password, will look something like this, where the length is actually more important than the randomness of the password, but it's usually a combination of uppercase, lowercase letters, symbols, and numbers. And one of the downsides of these strings, of these passwords, is they can be hard to remember, especially if you make them longer and if you make them complex. Now, a password manager can help you with this. But the easy thing is they can be hard to guess by others as well if they're complex. And that's why we use them all the time. If we use a complex, a longer, a secure password that nobody else is supposed to know, it's hard for them to guess them. And even if they try to brute force it, if it's long enough, it will take them a very long time, so it's not feasible to try to brute force your password. The second kind of password is a PIN code, and we all use this as well, probably on a daily basis. Maybe it's to unlock your front door, or to unlock the gate to your apartment building, or it's to get some money from the ATM, or it's to unlock your phone or your SIM card, and that's a PIN code. It's usually a few digits, not longer than 2, 3, 4, 5. Most of the time it can be longer, but usually it's quite short. And the downside to these PIN codes or to these alphanumeric or to these numeric passwords is it's not so hard to guess because we only have 10 different digits, 1 to 9 plus the 0. So they're often combined with a maximum allowed number of guesses. For example, if I want to withdraw money from the ATM, I only get 3 guesses. If I have 3 mistakes, then my card will be blocked. But they're fairly easy to remember. It's only 4 or 5 digits depending on your bank and maybe your country. But they're easy to remember because they are just a few digits. And they're usually only used with access to a physical thing, a second factor. Maybe that's your ATM card, maybe it's your phone or the keypad next to the door. But somebody who knows your PIN code is nothing with that PIN code unless they have access to that physical thing as well, a second factor, as we call that. The next up is a pattern, and we see this especially on modern Android phones where we can use a pattern to unlock your lock screen. But it doesn't matter that behind the scenes this gets converted to a something else, it's still the pattern that unlocks your phone. And usually when I do this talk live, I ask the audience who uses a pattern, and I see a lot of hands raised. And the main reason for this is it's very convenient. It's very easy. It's something that once you had it for a while, it's in your muscle memory, and you just swipe your pattern and you unlock your phone. It's very user friendly. But the downside is that touchscreens often reveal the pattern as dirty spots unless you clean your mobile phone after each time that you open it and you unlock it with the pattern. The chances are that you will see a dirty spot where you had your pattern input every time again and again and again. And people often use their initial letter or lucky number, so they might be easy to guess if you know something about the person who owns that phone. But the upside is, like I said, they're easy to remember. It's a pattern. If you use it long enough or a few times, it will get into your muscle memory, and you can just enter it without even thinking about it. So what is the problem with passwords? Because we've seen a few of those: a string, a pin code, a pattern. These are all passwords we see commonly during our days. But what's the problem with these? Well, let's see an example. On the screen, we see a very common login form. You have the username, you have a password, and a login button. Now, when you click on it, well, nobody has their password correct from the first time, right? So you type it again and try again. Second time, I must have been not paying attention, so I did something wrong again. Third time's a charm. No, I still don't have my password correct, so maybe I forgot my password. So what do? I'm going to try to reset my password, and then when I do that, I get greeted with this little message: your new password can't be the same as your old passwords. And I'm sure a lot of you who are watching this video right now have experienced this at least once in your life, that you think you forgot your password, but in essence, you were just not paying enough attention, or something went wrong while entering your passwords. And it's a very cumbersome, it's a very annoying process to enter your password over and over and over again, because it has to be perfect. And because we like to have these secure, longer passwords, it can be a very daunting task. Passwords can be very, very annoying. It's not the best user experience out there. But if you use a password manager, it can help you remember them, and it can also help you input them. So it's already a step in the right direction, but I don't think it's the best solution yet. Because another problem with passwords is that user data can get stolen. If we look at a few examples from some time ago, in January 2019, Marriott Hotel lost a lot of data. Facebook lost a lot of user data. Now, all of these hacks might not have included plain text passwords, thank God, but it does mean that people are constantly trying to get access to companies' data. MoviePass won 60 million, Words with Friends to 80 million, People Data Labs 1.2 billion, and these are very high numbers. And just today, I read an article that a new set of username and passwords was published online with more than 8.5 billion user records, which is an astonishingly high number of user records that was just published online. Luckily, Auth0 has this breach password detection feature that will notify both the user that is trying to use a password that has been known to be breached, that has been found in one of those sets of breach passwords, but it will also notify the owner of the website so they can force the user to create a new password. But if you don't use Auth0, there's also a Chrome plugin for that, and these days even Chrome supports this out of the box without the plugin. So Chrome can notify you, or Chromium browsers in general can notify you if you're using a username and password that have been known to be breached before, so you can change those. So some tips for a good password: use a complex password. Don't use something personal, so people cannot socially engineer your password. Don't reuse passwords. It's best if you have a separate password for each service, for each login that you create. And change password frequently. This is not really a recommendation anymore by the OWASP, so it's not that important. And when I say use a complex password, length is more important than complexity. It's the length what makes it more secure. But a combination of complex and length is the best choice to go forward with passwords. So let's fast forward a bit more. We've seen passwords, different types of passwords, and we've seen that they can be annoying, that they can get hacked, that nobody enters their password from the first try. So, of course, we're all clever engineers. We're trying to come up with different ways of omitting this process of entering the password. And the first approach is passwordless, and this can be in a lot of different ways. The first one is a one-time password, which is a password that gets generated on the fly when you need it. It's valid for one-time use, so you can only use it once. It often expires after a certain time, let's say 30 seconds, and it's sent directly to the user, directly to the person that wants to use this password. And this can be either in an SMS, and iOS and Android will let you fill in the one-time password with the press of a button. For example, here I'm doing my second factor on GitHub, which is a one-time password through SMS. And you see I get the message with the one-time password, and my keyboard on iOS already asks me, do you want to enter the one-time password from messages? So that's very convenient. But not all telecom operators take security serious, and SMS messages can be intercepted. That's a reality. It doesn't happen, but it can happen. And you need your cell phone on hand. Let's say if you're logging in your computer and your cell phone is in another room or it's downstairs, you might have to run downstairs to get your cell phone so you can get to the SMS and get to your one-time password. So it can be annoying. But they can also be sent in an email, for example, as a magic link if you want to log into Slack. Slack offers this opportunity that instead of entering your password, you can click on the email me a link. You'll get a link which contains a one-time password. And once you click on it, you're logged in. And the good thing is you don't need a second device, because usually when you're on your laptop, you have your mail configured. When you're on your phone, most of the time you might have your mail configured or at least access to your mail. So you don't need a second device. You don't need to be able to get that SMS if you're on your laptop, for example, which is convenient. But again, emails can also be intercepted. It's less common than SMS messages being intercepted, but it's still a possibility. And the third option for one-time passwords is an Authenticator app. And there's a bunch of them out there. This is a Google Authenticator app, which will generate a new one-time password each 30 seconds. We have our own, it's called Guardian. It does the same thing. It generates one-time passwords. And it can also just send you a push message on your phone, which you can then just press on the accept button, and you don't even have to enter in the one-time password if you don't want to. But there's a bunch of them out there. Dual has one, LastPass has one, Authy has one, Microsoft has one. 1Password has it built in. So there's a lot of choices out there for one-time password generating apps. And the good thing is they're often time-based, which means that these one-time passwords expire within 30 seconds or 60 seconds. Like you can see in the Google Authenticator example here, the numbers become red, the pi on the right is getting smaller, and once it runs out of pi, you'll get a new one-time password generated for all the services you have configured. They can also be push-based, like I said, or Guardian app, our own Guardian app, and some others out there can send you a push message on your phone, and when you click on the push message, it will do all the things you need to do for you, so you don't even have to enter that one-time password manually. It will do it for you. But they rely on a shared secret between the app and the Authenticator service, because we need the Authenticator service, the authentication service, and the application need to be able to generate a one-time password that's valid for the service you're trying to use. So once that secret gets out, well, everybody can create those one-time passwords. It's called a secret for a reason. We keep it secret, we keep it secure, but sometimes it might get out unwantedly. And then we also have social, and it's login with GitHub, login with Google, login with LinkedIn. This is not really a passwordless solution, but it's still a very convenient way of logging in for some people, including myself. I try to do it all the time if I have the opportunity. And the reason why is it's one less password to remember. If I want to log in with Google, for example, with my Gmail account, I only have to remember the password to my Gmail account, and all the other services that offer login with Google, well, they will use my Gmail account to log in, instead of that I need to create a username and password for each of those services. And it only means that I give a password to a service that I trust. If I choose Google again, for example, it means that I trust Google enough to handle my password and my username and password, so I don't have to give an extra password to a new service that I'm trying out, for example. But you also rely on that service, so you rely on login with Google for authentication, and if Google goes down, well, you might not be able to log into other services as well. It doesn't happen that often, but it's also a possibility. There's other authenticators apps out there. It's me, it's something Belgium. It's linked to your identity card. You have Yodi, which does facial recognition on the web. It's really cool. And you have VoiceIt, which does voice recognition, which is also a very cool service that tries to authenticate people based on something they say or they when they speak through the microphone. It does some voice analytics. So really cool services. And these often get used as a second factor, but in theory, they could also be used as a first factor. So those are the existing, very commonly used passwordless experiences. You have one-time passwords through SMS, email, the Authenticator apps. You have some other services out there. But it would be really cool if we could just get an out-of-the-box web API that would enable us to just get rid of passwords altogether. And I think last year, a new web authentication API was standardized. The spec was fully standardized and complete. And the Web Authentication API, often abbreviated as WebAuthn, is an API implemented by browsers that will help us do key-based authentication on the web, which means that we have a private key that we keep private and secure to ourselves, and a public key, which we then will use to authenticate on the web instead of a password. So how does that work? Well, you rely on hardware authenticators. There's also a few software solutions, but in theory, you have to rely on hardware authenticators. And these are things like this. There's a YubiKeys and Titan keys from Google. You might have an open source one, or you might have something fancy like the Trezor here on screen, which is actually a Bitcoin wallet, but it also knows how to do WebAuthn. And they can connect through your devices through a whole lot of different connections. You can have USB ones, USB-A or USB-C, depending on your device. Bluetooth, low energy, NFC. So depending on which device you use, you might find an authenticated device that can connect to it. Bluetooth when you're on your phone, USB when you're on your laptop or desktop computer. There's always something out there that you can use. So I usually ask the crowd who has one, and I cannot see your reaction now, but chances are I can see a few hands go up, but not everybody is raising their hand at this point. But if you have one, I have one connected to my computer, or I will connect one. If I click on login, I, in theory, don't have to enter a password. I just say, hey, it's me, it's Sam. Can I please log in? I click on login. I attach my key, touch it. And mine is connected with a PIN code, but that's not always the case. Touch it again. And because I'm on localhost, I have to allow it. But what I just did was I got a challenge sent to my authenticator device, my YubiKey that I just attached to my laptop, and it signed that challenge and sent me back the signature so I can verify this. How this works, we'll see in a second. But I basically just logged in by touching my authenticator, my YubiKey twice. And because mine is protected with a PIN code, that's an extra step, but that's not a necessary step in some use cases. So logging in without a password, you just touch your YubiKey, you just touch your Titan key, whatever key you have available for you. But the good thing is that most modern devices and most modern operating systems have one built in. So you don't really need to have an external one. You don't need a YubiKey or a Titan key or one of the other solutions out there. You can just use your MacBook, or you can just use your iPhone or Android phone or your Windows computer to do this for you. So if you take the same example as before, and I click on login, instead of me having to touch my YubiKey, my browser now just asks me to touch my Touch ID, which is part of my MacBook Pro. And when I touch Touch ID, I get the same thing. We send a challenge to a chip in my MacBook Pro, which did the same thing. It signed that challenge using my private key and then gave me back the signed challenge. So now we logged in on the web with just touching my Touch ID on my MacBook Pro, which is really cool. I didn't have to enter a password. All I had to do was touch the Touch ID on my MacBook. And the same thing is true if you have Touch ID or Face ID on your iPhone or the equivalent on Android phones, or if you have Windows Hello with facial recognition, it also knows how to do this with just facial recognition, which is really cool. So how does this work? Because it does seem like a bit of magic. It's not something we have seen before on the web. So the first thing is we need to create new credentials. The same thing as when you want to register for a service using a password and a username, you have to create a new set of credentials. So you register yourself, And you say, hey, my name is username, my name is Sambigo, my name is Sam. And you enter that in the website, and the website is going to send it to your backend, and the backend is going to save that somewhere and generate a challenge. And a challenge, you can see this as a random number. It's an array buffer with random values, but your backend, your API is going to send this back to the browser, which will then show this to your authenticator device, either your external one like your YubiKey or your internal one like Touch ID, which will then just generate a private key and a public key for this website only. It will use that private key to sign the challenge and send you. Usually you have to do some user interaction, so you have to touch the Touch ID or your YubiKey. But once you've done this user interaction to verify that you are present behind your device, it will send that signed challenge together with some public key information to the browser, which will then be able to send this to your backend. And because we send this public key and signed challenge, we can verify, we can save this data. It's a public key, it's public data. We can save this link to your account, and we can use this public key in the future to verify that the same private key has signed a future challenge. So now we registered one. We created a new private and public key pair on our authenticator device, only usable for your website. So it's phishing proof. Next thing, the next time the user comes back, we want to authenticate. So the user is going to say, hey, it's me again, it's Sam. Your website is going to do a request to your API, your backend, and it's going to say, hey, do we have some WebAuthn credentials saved for Sam? When your API says, yes, we do, it will send you your challenge, a new random array buffer, together with the public key, which is not the public key, sorry, that's a mistake. It's a private key, raw ID. And that's the ID of the private key you stored on your authenticator device, on your laptop or on your YubiKey. So it will send this to the browser. The browser, again, will send this to your authenticator device, to your YubiKey. And once you've done a user interaction, it will check if it has that private key with the ID that we stored in our backend. If so, it will use the same private key to sign the challenge and send the signed challenge together with some public key information again back to the browser, and then you can relay that to the backend. But because we saved that public key data, we can verify that it's the same private key that signed the challenge when we registered and each time when we log in. So we're now logging in using a public and private key pair instead of a username password, which is much more secure. And because it's implemented by the browser, we can skip passwords altogether. So to recap, when you're registering, you request a challenge, an array buffer with some random values. You sign that challenge using a private key that you just created for the website, and you send back the signed challenge together with the raw ID of the private key, not the public key, and you save that data in your backend together with a username. So you save these as WebAuthn credentials linked to your username. And the next time your user comes back, you check your database, do you have some credentials? If so, you request a new challenge, a new random array buffer. You also check for the raw ID of the private key saved in your backend, and you send that to the browser, which will forward it to your authenticator device. That authenticator device will then check if you have a private key with that ID available, and if so, it will use that private key to sign the new challenge, and you can then forward the signed challenge back to your backend, which has stored the public key information belonging to the private key. So you can verify that it's the same private key that signed this challenge and every future challenge and every past challenge as well. So let's look at some code, because we are engineers, most of us. So we want to see some code once in a while. So if you want to check if the browser supports WebAuthn, it's a browser API, so you can just run this JavaScript code, public key credential.is user verifying platform authenticator available. It's a very, very long method name, but it basically just gives you a value that, yes, my browser supports WebAuthn, or no, my browser does not support a verifying platform authenticator. And then when you want to create new credentials, again, it's a browser API we can call navigator.credentials.create, which will let us generate a new set of credentials for your website. And in that, you can give some configuration about the public key. The first thing, we're going to get the challenge from the backend and send this set this in this configuration object for the browser API. So this is our random array buffer. Next up, some information about the relaying party, your website. My website in this example, your website when you try to implement this. You give them some information about the user, an ID, which should not be identifiable by external parties. And you can also specify a name and a display name. And then some information about which algorithms you support. So you know how to deal with, in this case, I'm saying algorithm -7, but if you look at the link below it, there is a whole list of algorithms where -7 corresponds to the ES256 algorithm. So you can just use the abbreviations with the numbers, the values from the IANA list in here as well. So here we're just saying, I know how to deal with ES256. Please, if your authenticated device supports ES256, please use that algorithm to sign my challenge. You can set a timeout in milliseconds, which means that we have 15 seconds to complete the whole touching of YubiKey or touching of Touch ID. And you can also exclude credentials if you want to exclude certain previously created credentials for a user for some reason. And lastly, you can give some more, or you can configure some more details about the authenticator you would like your user to use. You can either let them only use platforms, so built-in ones like Touch ID and Windows Hello, or external ones, roaming authenticators like YubiKeys, or just give them both. You can specify this in the authenticator attachment option. You can only allow authenticators that do user verification. For example, my Touch ID can verify it's me based on my fingerprint, while my YubiKey can only verify that somebody touches it, but it cannot verify that it's me personally. So that would not verify the user, it would just verify presence of a user. And then requires a resident key. We'll see this in a second. And lastly, you can set your attestation if you would like to. That's a bit more complex, but it basically allows you to do second factor out of the box with WebAuthn. And that's all you need to do. You just call navigator.credentials.create. You supply the config you would like to specify. Most important thing is that you give it a challenge, and the browser will take care of the rest. It will present that challenge to your authenticator devices that it has available. It will generate a key pair, a private and public key pair, and it will use a private key to sign the challenge and send all of that data back to your browser so you can forward this to your backend. So then the next time the user comes back and wants to authenticate user WebAuthn, you do navigator.credentials.get. We use .create to create the new credential, and you use .get every time you want to authenticate it. And again, it accepts some configuration, the challenge, the random array buffer, which is going to sign with the private key stored on your authenticator device. You can specify an array of allowed credentials, and these are the raw IDs of the private keys that you have stored linked in your backend linked to your user. So the first time when you register, you get back the raw ID of the private key that it generated. You can pass it along in this array so that the browser knows to ask the authenticated device to use that private key. And then again, you can set user verification to preferred if you would prefer an authenticated device that does user verification instead of a user present test. And that's basically all you need to do on the front end. You just call navigator.credentials.create to create a new set of credentials. And next time you just do navigator.credentials.get. But what do we need to do on the back end? Well, that code is a bit more complex. But when creating a new credential, we're basically getting back a bunch of data from the browser from that navigator.credentials.create method. It will return an object with a bunch of data. It might look like this. But what's in there? There's a raw ID and ID of the private key. And there's also the response, which has some more information about the client data JSON and the attestation object. Now, if you expand the client data JSON, if we parse the result of that, it will tell us that we did a WebAuthn.create method, the original challenge, so we can verify that if we want to. The origin, we are doing this on webauthn.me. This is a website I'll show you in a second, and it was not cross-origin. And if we parse the attestation object, it will give us a bit more information about the public key that is related to the private key. As you can see, the credential public key contains a bunch of information that you can save safely in your backend, and you can use that public key information in the future to verify that it's the same private key that signed the challenge as that private key that you used now to create the new credential. So what are we doing? We validate the returned authenticator data. Is there an ID in it? If so, we validate the returned client data. Is there a challenge? Is it the same challenge that I sent initially? Is the origin okay? Is it not some other origin? Is it for my website? You can also validate the returned attestation data, or just parse it or send it to your backend so you can save the public key information. And then save that credential ID and public key information linked to your user so you can use it whenever the user wants to authenticate using WebAuthn. And when you want to verify an existing credential, when the user wants to authenticate, you get back the signature, which is the signed challenge. You get back the user ID and some more information about what happened. WebAuthn.get, we did the original challenge, the origin, cross origin again. And then also a hash about the relaying party and some other information. But the most important thing that we get back once we want to authenticate a user is the signature, and we can use our stored, saved private public key information in our backend to validate that the signature is created by the private key we expect on our authenticator device. So what we do is we validate the user and credential. If that's okay, we validate the return signature. And if that's okay, we are safe to log in the user without them ever having to enter a password. Lastly, a word on resident credentials. And I'm just going to show you how this works because it's easier to demonstrate it with a demo. If we go to webauthn.me/debugger, we basically have a debugger available that we created where you can play around with all of the configuration objects of the navigator.credentials.create and .get methods. So if we would type in the name of the user, React, and the display name, React Norway, and if we would enable the authenticator selection and requires a resident key, this will enable us to save not only the public and private key information on our authenticator device, but also some information linked to our username. So in this instance, we will save React and React Norway as name and username together with a randomly generated ID for this service linked to our keys. So once we do that, I have to enter my PIN code and touch my YubiKey. But once we did that, we can get the output that we just saw in the previous slides. We get the client data JSON and the attestation object. We can send this back to our backend. But the next time the user wants to authenticate, it doesn't even have to tell us that, hey, it's me, it's Sam. We'll just unclick allow credentials, and we're just basically going to do a navigator.credentials or get without any extra configuration. And we're going to ask the browser, hey, did we save a user information for this website together with a public and private key pair? If so, can we please use this? And if we do that, and I enter my PIN code again, and then I touch my YubiKey, you can see that we saved information for 3 users for this website, including the React Norway. So we don't even have to tell the website, hey, it's me, Sam. I can just click on my username, and it will authenticate using that username and the public and private key pair that it's stored securely on your authenticator device. So not only can we get rid of a password, if you use the requires resident key option of WebAuthn, you can also get rid of the username input, which means that your login would basically just become a big button login. And if you omit that button, you can just automatically pop up the request for touching the YubiKey or touching Touch ID, and an authentication would go automatically. Like I just showed you, if you want to enable the resident key, you just set require resident key to true in your authenticator selection in your configuration object when you create credentials. So in the first step, and if you don't have one of those authenticator devices, and maybe your laptop doesn't have one, the Chrome DevTools also supply a WebAuthn tab, which will let you emulate any type of authenticator device. So you can choose which protocol, which transport. It lets you figure USB one, for example, and then you can enable supports require resident key and supports user verification. So if you're debugging or if you're trying to build a WebAuthn implementation for your website, the Chrome WebAuthn tab in your DevTools is definitely something I can recommend. If you'd like to look more at the WebAuthn debugger, you can find it at webauthn.me/debugger. And on this website, we have a bunch more information. We have a small tutorial where it shows you the back and forth between the authenticator, the browser, and the relaying party, which is your website, your API. It's all mocked, but it gives you a nice visual explanation of what's going back and forth. For example, if I enter my name, and this doesn't even have to be your name, you can see that we're requesting a challenge to the backend, forwarding it to the browser, sending it to the Authenticator app, and once that happens, you have to authenticate. So I have to touch my YubiKey, but once I do, you see that I can send the challenge, and the public key information is forwarded to the relaying party, and that's the data. And then you can see the same step for when you authenticate. You're going to supply the ID we just created, or we just got back from our first step, send that to the relaying party. We're getting the raw ID and a challenge back. Send that to the Authenticator app, enter my PIN code, and touch my YubiKey. And once everything goes back and forth, we see that we have logged in with a WebAuthn. This is all mocked, so it's completely safe to use. We don't send anything to an actual server. It's just so you can see what's going back and forth. And we also have a page with a bit more of information if you want to read more and see some code, together with a test to see if your browser supports either roaming authenticators or built-in platform authenticators like Touch ID, and a nice overview of all the most commonly used browsers on Windows and Mac OS and the mobile operating systems. So if you want to know more about WebAuthn, webauthn.me is the source to go. So there are some issues to be solved still. The first one is user credential management. There's no real easy way to manage the stored credentials on your YubiKey or on your laptop or phone, which you can use with Touch ID or Windows Hello or whatever. And that's something that still needs to be figured out. Now, if you look around in your Chrome options or Chromium options, you will see a manage sign-in data and reset your security key. But I have never seen this work the way I expect it to. So it's still something that is under construction and needs to be figured out how to do this better, how to manage all the public and private key pairs that we have created and stored on our authenticated devices, and do this in a secure way. If you use a YubiKey, you can reset your YubiKeys, which means that you erase all of the existing saved credentials, but there's no way to choose one or two of those credentials, or it's either all or nothing. So managing these credentials is still something that needs to be figured out for a better user experience. The next thing is cross-device credentials. If you create a credential on your MacBook, you cannot use that same credential on your phone just because they're stored on the device itself, unless you have a roaming authenticator that works both on your MacBook and your phone. For example, I have one that has both a USB-C and a Lightning connector, so I can use that external authenticator for both my devices. But if you create them on your MacBook, on your phone, you cannot really share this. Until yesterday, Apple announced that they will, in the future, allow you to save these credentials in your Apple keychain, which will then sync through iCloud, which means that if you create them on your MacBook, they will also be available on your iPhone and your iPad. This is something for the future, but they announced this at the WWDC conference, which is going on at the moment, and they gave a nice presentation about that yesterday. And then lastly, when you lose your authenticator device, if I lose my YubiKey or it gets stolen, there's no way to recover that key. It's gone. And that's why you always need to have a second way of logging in to recover your account in case you lose or break your authenticator device. And this might be a password. This might be some recovery codes. This might be another way. But if you use WebAuthn, be sure that your users always have another way to at least recover their account and to generate a new WebAuthn credential should their authenticated device be lost or stolen. So WebAuthn might replace passwords. I think it does. It's being taken seriously by both Apple and Google, which are the two biggest fans of it, and Firefox also has basic support for it. But there's a lot of big companies driving this at the moment, and it's getting a lot of traction, which is nice. But it will never or will not replace token-based authentication and authorization, things like OAuth and OpenID Connect. It will not replace identity providers like Auth0 and others, just because it only replaces that little part of the login experience where you have to enter your username and password. And instead of entering the password, we're going to use WebAuthn to use a public and private key-based authentication instead of a password-based authentication. It's a W3C recommendation, which means that the specification is finalized and it will not change, at least not this version. And it's supported in all major browsers, both on mobile as on desktop. Only if you want to use it on iOS, I think only Brave and Safari supported. The iOS version of Chrome and Firefox do not support it, I think, unless they recently added support for that, but that's because they run in a web view, which is a bit limited by Apple. So where can you use this already? Every service that uses Auth0 can use this or can configure this. Google supports it, GitHub supports it. Most of the major services and websites out there have support for it, maybe as a second factor at the moment, but definitely a first factor is being worked on by most major services, including Auth0. Again, if you'd like to know more about WebAuthn, you can go to webauthn.me. I'm in Europe, so I have to deal with GDPR pop-ups, unfortunately. So let's summarize. Boo, passwords. I don't like passwords. They're annoying. They get stolen. You have to remember them and type them correctly. One-time passwords are cool. One-time passwords can make logging in certain scenarios a bit easier, but they're still a hassle most of the time. And WebAuthn is way cooler because the only thing that I need to do is touch my Touch ID or touch my YubiKey, and I would be logged in, which is so much more convenient than remembering and entering passwords over and over and over again. And it's more secure because it's based on a private and public key pair instead of a stored password in a database. Again, if you want to know more, webauthn.me is our website with the demo, the debugger, a lot of information. And the specification is surprisingly readable for